Hello, space fans, and welcome to another edition of Space Fan News. Now, for those of you who've been following me from the beginning, ever since Space Fan News #1, you know that I started doing this because I wanted to report the discoveries announced from the January 2011 meeting of the American Astronomical Society to you. Well, from those sad days when I was doing a telecast from my desktop, if you'll go back and check, we've moved up a little in the world now, and now I get to go to the meetings. And last week, I live streamed a bunch of it on Ustream for the Space Telescope Science Institute. Now, I posted a link to that channel down in the description box if you want to see any of those streams, so you haven't missed anything. Doing that last week, however, meant that I didn't really have time to post anything to this channel this week like I usually do during that week. So tonight, I'm going to give you a live recap. First up, on Monday, the Kepler science team reported that on 4 years of ground-based follow-up observations targeting Kepler exoplanet systems. It turns out that more than 3/4 of the planet candidates discovered by the Kepler spacecraft have sizes ranging from that of Earth to that of Neptune, which is nearly 4 times as big as Earth. Now, what's strange is that these sized planets are the most dominant in our galaxy, but are really not represented in our own solar system. Furthermore, astronomers don't know how they formed or if they are made of rock, water, or gas. The observations reported at the meeting have confirmed that the numerous Kepler discoveries are indeed planets and yield mass measurements of these enigmatic worlds that vary between Earth and Neptune in size. Included in the findings are 5 new rocky planets ranging in size from 10 to 80% larger than Earth. 2 of the new rocky worlds, called Kepler 99b and Kepler 406b, are both 40% larger in size than Earth and have a density similar to lead. The planets orbit their host stars in less than 5 days for Kepler 99b and 3 days for Kepler 406b, making these worlds too hot for life as we know it. Now, a major component of these follow-up observations were Doppler measurements of the planet's host stars. The team measured the reflex wobble of the host star, caused by the gravitational tug on the star exerted by the orbiting planet. That measured wobble reveals the mass of the planet. The higher the mass of the planet, the greater the gravitational tug on the star, and hence the greater the wobble. Next, Tuesday was Frontier Fields Day. Now, Frontier Fields is a major observing program for the Hubble Space Telescope that will take place over 3 years and utilize close to 600 orbits of Hubble observing time to image 6 gravitationally lensed galaxy clusters. These clusters act as an actual lens and allow Hubble to see things it wouldn't otherwise be able to see. Now, to help explain things a little bit better, here's a video produced by Dr. Frank Summers, which I think does a pretty good job of describing the program.
For 2 decades, the Hubble Space Telescope has peered ever more deeply into the universe. From the groundbreaking Hubble Deep Field to the subsequent Ultra Deep Field and its infrared extensions, Hubble has revealed galaxies stretching towards the edges of space and time. Although further infrared exploration awaits the launch of the James Webb Space Telescope, researchers have yet one more trick up their sleeve. Einstein's theory of relativity explains how light, passing near a massive object, is bent by the curvature of space. A massive cluster of galaxies can act like a lens to gather and magnify light. This natural telescope of a galaxy cluster can extend deep field observations and help astronomers uncover fainter and more distant galaxies. NASA's great observatories, Hubble, Spitzer, and Chandra, have now launched an ambitious multi-year project called the Frontier Fields. A set of galaxy clusters will serve as gravitational lenses that probe to the ultimate depth of Hubble's capability, while a set of neighboring deep fields will diversify, enhance, and extend our studies of galaxy development. This community-developed program of cosmology research will examine galaxies in their earliest stages of formation and growth, providing a sneak peek at the first billion years of the universe.
By late December 2013, Hubble had completed its observations of the first 6 clusters in the list, known as Abell 2744. After staring at the cluster for 67 hours, the Hubble image reveals nearly 3,000 distant background galaxies interleaved with hundreds of foreground galaxies that make up the cluster. These background galaxies would not have been seen without the boost from gravitational lensing. Their images not only appear brighter, but also smeared, stretched, and duplicated across the field. In addition to looking at lensed galaxy clusters to see very distant galaxies, at the same time, Hubble will turn on another camera, the Advanced Camera for Surveys, and stare into deep space, making another ultra-deep field in the process. And in the end, we will have 6 more equivalents to the ultra-deep field. Now, by the time Frontier Fields is over, Hubble will have pushed the limits of what it can see and help us answer the question, does the universe look like the ultra-deep field everywhere in the sky or just in certain spots? So finally, on Wednesday last week, we got an update from Eric Smith, the Deputy Program Director for JWST, on the status of the JWST mission. He said that everything is still on time and on schedule, and that the sequester only put a small dent in the amount of reserves that they had allocated, which was something like 14 months. And it may be down to, as far as we know, I think might be down to about 13 months at this stage. Now, all missions do this, especially ones as large as JWST. The schedulers that designed the project build in some reserve time to deal with unexpected problems or to implement contingencies, and the sequester just used some of that reserve time. So all is well with JWST, and is still on track to launch in late 2018. Now, I did ask Eric because the idea popped into my head when I was talking to him. I asked him, I said, if there were no problems at all, and we have all this contingency built up, would JWST be able to launch earlier? And what he said was that, well, maybe a little bit earlier, but what you have to remember is that there are other people, like the transportation people, other parts of the project, that are working on a certain schedule, and they might not be ready. So you may be ready, they may not be. So like the telescope may be built, but the barge to take it down to where it's going to be launched won't be built. So there's all these things that have to kind of come into play. So I think we're going to still have to wait for 2018, even if things go perfectly. So we'll have to be patient. Well, that's it for this new live episode, space fans. I hope you like the new format. Thank you for watching. And as always, keep looking up. Now, there were a couple of bloopers in there, but as you saw, it wasn't super big. But I want to show you something. Scott Lewis made something that I think sort of qualifies as a blooper.
This week, I'm going to be covering the JWST 223rd meeting, live on the internet. Come join me at Hubble.
All right, well, so there was that. Now, if you are only interested in watching the episode part of Spaceman News, you can go ahead and turn it off and go away, because that was the episode part. Now, what's coming up now is the live part, the part where I hope we get to interact with each other a little bit more. So I did not expect a whole lot of questions for this first one, because we are, this was our first one and nobody really knew about it or anything like that. But I did get a question on the trailer video that I made from J.J. Thompson. He goes, "Hi Tony, I'm a fan, I've been watching for a while. Just a quick question. There's an asteroid called Apophis that is said to be heading our way for 2029 and again in 2036. Can you give us any information about this? Hopefully you can put our minds at rest. I understand you'll be very busy, but any feedback would be greatly appreciated." Well, no, that's sort of why we're doing this. So I actually made a video already on my channel that is about Apophis. It's called Apophis, the Apophis asteroid, What You Should Know. I made it a few years ago, and it outlines the problem, what people are afraid of, and it isn't going to hit us. That's the good news right away. Hey, Scott, are you there?
No, I'm not here.
Oh, okay, good, good.
You're hallucinating from all the pressure.
Yeah, Scott Lewis was doing the graphics in the background, and just sort of directing the whole thing. So we're gonna
Actually,
watch.
I'm Tony Darnell. And
Not to mention that. Yeah, thank you for that, Scott. I appreciate it.
no problem.
So there was that one part where you were playing the video, and I'm like just sitting there because I had muted my sound. I had muted my sound because you told me to, and I couldn't. I couldn't tell when the video was over.
You're on.
I know. And finally, you're like, go. So there was a blooper, folks, live and in person. So anyway, back to Apophis. It's called the Apophis asteroid. What do you need to know? And the thing about that, where I left it off was that the 2026 flyby was not going to, or the 2029 flyby was not going to hit us. But depending on exactly where it does fly by over the Earth, it's going to pass between the Earth and the Moon. Then it will, depending on its exact path, when it flies by in 2029, will determine whether it hits us when it comes around again in 2036. And so where that video left off was saying, because Apophis was in a spot that was hard to observe, and it was just coming around in its orbit in a place where we could get more observations. NASA was going to get some observations early last year in 2013, which they did get. And so I should update that video. It is almost certain that it's not going to hit us in 2036. So that asteroid, while it is very large and scary, it's not going to hit us any. So that's how so thank you, J.J. Thompson. That was a good question. I wanted to make sure I answered that. So let me get some. Are there any comments, Scott, on this?
There's a lot I'm deleting because spam. But
okay.
And actually one here saying that, let's see, and to think all those galaxies are up to 6,000 light years away. No, galaxies are much further out than 6,000 light years, just because the size of our galaxy alone is enormous, well beyond that, hundreds of thousands wide. So these galaxies they're very far away, and they're getting further away due to the accelerated expansion of the universe. Pull some more up here. Let's see. People are talking about Rosetta with ESA. Yes, that's another big thing coming out too. ESA went a bit viral about Rosetta resuming. So I know there's a big initiative out there right now for Wake Up Rosetta, which I think is kind of cute. I think I would have done like a Sleeping Beauty fairy tale to go along with that if I was doing their PR. But maybe next time we have a spacecraft wake up.
Yeah. So militant anti-theist is going, that's what they want you to believe. Apophis is a code word for planet Nibiru. Oh, my. And the government is hiding its approach with holograms. Wake up, sheeple.
It's true. Wake up, sheeple. So just so you know, Nibiru was Comet Ison until NASA caught on that you guys knew it was Nibiru, and we shot it out of space. We're waiting for the next Nibiru to come up.
Yeah, but in all seriousness, it's funny how with NASA's funding and the inability to barely keep the ISS going and the programs that it is running going, that there is resources available to block out planets and hide things like that. So
but that's just what NASA tells the sheeple. Tony.
Maybe that's where they're sending all their money. And I don't even know what they would have to gain from something like that. I mean, why would it be even if there is an asteroid heading straight for us and NASA knew, why would they benefit by not telling us? I mean, I don't understand the thinking there. What do they have to get out of it? I mean, this is a worldwide thing. It's going to hurt us all.
And, I have a somewhat benefit of being outside of the publicly funded stuff. So, so I get to interact with NASA scientists. And first of all, scientists are terrible at keeping secrets. Absolutely terrible at it. If they have something
evidenced by what's going on with Edward Snowden right now. So.
Yeah, it's just if they find something, it is so hard to keep it under wraps, especially if you're at a conference and some social lubricant's been poured into glasses. So I think all the really out there ideas, okay, if you want to look at it with a skeptical eye, but all the scientists that I've ever met are the worst at keeping secrets. They are so excited and so passionate about their work. As soon as something groundbreaking comes through, something amazing, they're all out. They want to tell everyone as soon as they can.
Yep. So, okay, let's read the good with the bad. Where was it here? Prefer BBC Stargazing Live. You guys suck.
Yeah, well.
Well, it's our first time, and if you don't like it, that's what we want you to tell us. Is whether you do it. It's good to be on YouTube, though. It really is.
It is, and I don't have the voice of Brian Cox. Yours is closer to that.
Mrs. Sawbones asks, "Is there a critical distance for stars to be binary?" Love the live stuff. Thank you, Mrs. Sawbones. I love you. Is there a critical distance for I don't know what you mean by critical distance. There's a point at which they can be too close, and then they'll fall inward on each other, but that depends on the sizes of the stars and their relative masses to each other as well. So there's a lot of orbital stuff that goes into that, but I think there is a critical distance, but it's going to be different depending on the specifics of the binary, and where they finally settle out. Because some stars will be traveling too fast past each other, and they won't capture, or they won't stay in the same orbit. Or when they form, if they form from the same primordial cloud, then they might collapse, or they might actually do a stable orbit. But again, it just depends on how they all come together in the beginning. So.
I see I have another comment here by Cybercharger. Will JWST be able to see the atmosphere of extraterrestrial planets in visible light? And that answer is no. JWST will not be looking into.
It's an infrared telescope.
Right.
So it's all infrared.
Which is why it's so big, because the infrared wavelengths are larger than the optical wavelengths. So you need an even larger mirror to be able to resolve all that.
But using the spectrometer that they're building on there will be able to see the atmospheres and what they're made of. So hey, Ciro, he goes, "I'm an alien." I am an alien. That's true. That's true.
It is true. My name's Tony Darnell, and I'm an alien.
Patrick Smith, what do you think about the rock that appeared on the Mars rover site? Wasn't there yesterday? So they say. Sorry, I don't know anything about it. Do you?
Oh,
Scott?
Yeah, I've seen something about it. That could be so many things. We have so many impacts on the moon and Earth all the time too. I would be willing to. I don't bet, but if I did bet, I would bet 5 million space bucks that it is from some sort of meteorite impact. Whether it be, it's not. I don't believe it's a meteor itself, but the remnants of a meteor impact. That's what I think is going on with it. I don't think it's anything crazy. Moving alien rocks, no. I think it's just something that can be easily explained. Like, there was an impact, and that is what happens, because when you have it, you have ejecta. When you have a meteorite hit, ejecta flies up, and it has to land somewhere, and it just happened to land in front of Curiosity, which is awesome, because that means we can study it.
Okay, Moppers 2, is there any plans for a new visible light space telescope after Hubble? No, because the real scientific wavelengths that are the most lucrative right now are the infrared, and the reason for that is that to study far distant galaxies, their light has been redshifted into that region of the spectrum, and so that's where most of the interesting science is being done. The optical, not so much. In fact, even Hubble's not really an optical telescope. The Advanced Camera for Surveys does have some wavelengths in the optical, but it's primarily an infrared telescope now too. Right. So that's the so there are no plans for infrared. The future of astronomy is in the infrared. I've said it before. And
the reason behind that is because what we're using these great observatories to do is look further back into space and time, and because of this expansion that's happened, the light is being stretched out. So what might have started even as X-rays over billions of years has been stretched out, that they're in the near infrared and infrared. So we want to be able to see in these infrared wavelengths, and just like radio astronomy, like our friend Nicole, it's looking at even larger wavelengths of light, because that's stuff that's been stretched out so you can look further back because of how that light's worked.
Enigmas, what are you looking forward to the most in 2014? Now, we did a thing called The Year in Astronomy 2013, and we did that back in December 27th, so there's a video where we had a hangout and we talked about some of that stuff. But
there's so much going on this year.
Yeah.
Mine is a Gaia.
Yeah, I would agree with that. And me also, because I have a bias, the Hubble, the Frontier Fields initiative, I'm working really hard with that because I think that's an amazing program. Imagine 6 more ultra-deep fields after 3 years. They're going to be staring at the sky for 600 orbits, and each orbit is an hour and a half long. So that's what I'm looking forward to results from Frontier Fields as well. Ashley Hines, can a planet sustain itself if it was orbiting a binary star system, sure. And I even think they found some exoplanets around a binary star system.
have, yeah.
So yeah. Now, whether it's in the Goldilocks zone, this area where liquid water can be present, that's possible too. It just depends. It just may be farther away. A lot of it depends on the nature of the binary star system itself. PC tweakers. I'm going through these quickly because we're getting so many, and I don't want to take up longer than a half an hour total, just because I think people prefer brevity.
You've got a date. Let's.
No, I don't. I just prefer people prefer brevity on these things. Deep astronomy. Do you believe in life on other planets? I do. I think that it's extremely likely. I think that one day. Well, I don't know that we'll ever find it or even communicate with it, but do I think it's there? Yes, absolutely. I don't have any doubt that there would be life on the hundreds of billions of planet or stars and the hundreds of billions of galaxies in the universe. I mean, think about it. Even in our own galaxy, we've already discovered that every star in our galaxy has 1.6 on average planets around it. And come on, that's more planets than stars in our own galaxy. So for every star you see in the universe, there's probably a couple of planets in orbit around it, and of course, there's going to be some chance of life having formed there. So I do believe it's. I don't believe life is ubiquitous to here or special to here.
And there's actually a quick related question too. Do we believe that we'll find life within our own solar system, maybe on Europa or subsurface Mars? I would love to. That like the stuff that I've worked on, I would love to, either on Europa or Titan, but I don't think we're going to, but I would love to. I'm not optimistic that we'll find any sort of microbial life anywhere, but that would be freaking awesome.
Steve Epic, do you think there is a large magnetic field around the perimeter of space? If yes, do you think that these magnetic fields are pulling the planets toward the redshifts? Can this be possible? I don't think I understand the perimeter of space parts. There are magnetic fields. There's large ones around all kinds of things in the universe. So, but if you mean does the perimeter of space itself have a magnetic field, I don't think.
Because I think that implies that space itself is finite, and that's really going against what we know so far of what physics, of how physics works. We don't know everything about physics, but for what we know, it's infinitely expanding and growing. So to have a perimeter on something that's growing at such an exponential rate, that's going so far, I don't think that's something that we can really say would have a magnetic field of that type. We have magnetic fields around something like our sun, which is how Voyager was able to leave the heliosheath. It stopped at that point where it wasn't interacting with some parts of that. But as far as saying that there is an outside to space, that's something that there's really no evidence for that I know of.
Cool. Bakakorg, I've been watching since 2009, 2010. That is great. Remember in 2011, I just decided. I remember the AAS was starting up, and I'm like, I want to talk about these things, but I didn't have time to make little mini doc videos about every single thing that happened. So I started just talking about it in front of the webcam, and then I made this sort of arbitrary threshold. I said, okay, if 2,500 people watch this, then I'll keep doing it, and that happened, and you guys kept watching it, and then after it was over, after the meeting was over, I asked you guys if you wanted me to keep going with it and do it on a weekly basis, and we did. Today was episode, we are starting our 3rd year doing Space Fan News, and this was episode 123, so thank you guys for watching and hanging in there, and I don't know how this is going to end up. You guys may or may not like it. You may like the 5-minute, doing it thing, but I got to tell you, 3 years at this, what I wanted was I needed to kind of do something fresh and new because I was kind of dreading making Space Fan News as they were getting kind of a little bit monotonous.
Well, that's why I brought the young blood into here.
Fresh. So Scott was helping me out, and I needed something to keep me challenged and pushing the envelope, and so that's why I did this. We started discovering live streaming over, of course, with Google Plus Hangouts. We've been doing those. Now, I realize an hour is too long for most people, and what's worrying me about this is that if it's a half an hour long, it'll be too long for you guys. So that's why I did the format I did. I did the episode as I would have done it, any other time, and then I stopped. And then anybody else if you don't care about any of this other stuff, you can just go. But if you wanted more information, or if you had a question about last week's episode or the current one that we're doing, then you can interact now and make it a little bit easier. And I actually think, and I told this to Scott before we started, I actually think this is going to save me some time as well. I think that we can do this in a much quicker time period. I had gotten it down to where it took me 4 hours to do a Space Fan News episode. It used to take me 10, then I got it down to 6, and now it was down to where I could do 4 hours from writing the script to uploading to YouTube. But it was getting to be kind of mechanical, and I wasn't enjoying it as much. And so I wanted to do something to get me re-engaged. So that's why you're seeing this. I may just edit out the first part of the episode so that people can watch that separately, and then leave this for everybody who would like to watch the other stuff. But let me know what you think. You guys are great at that. You guys are really good at telling me.
And we're not afraid to mix things up. If there's something out there that either we think would work better, if you guys give us some really good feedback on some suggestions, we experiment so much that what you guys don't see. Tony and I spend so much time hating our computers, just trying to get things to work the way we want it to. So we're always looking for new ways to just make things more fun, but also get that science out there as much as possible.
Yeah. So, okay, we'll just a couple more, and then we're going to cut it off. T with Grief. Mars One project is taking up speed. Do you think it's even a good idea or even doable? Mars One. Why don't I know about? I believe
Mars One is the one-way trip, which I would totally go on.
Sure. Of course, it's doable. And as with all of this stuff, it comes down to the will. Do we have the will to do it? I mean, going to Mars is a doable thing. Last I heard, back in the 80s, it was going to cost $300 billion in 1980s money. So God knows what it's going to be now. But it's a big deal, and it's something that I think it's probably out of the reach of one country to pay for. I think it's going to have to be an international effort. But yeah, if it's building up speed, and if someone is doing it, then sure. I don't know about it being a good idea. I mean, it's a one-way mission. I mean,
it is a one-way mission. I think not only is it going to be multiple countries or agencies, but we're in the age now that we have commercial spaceflight. And it's becoming cheaper to do things like, with SpaceX, for instance. And so being able to utilize our resources more efficiently and, just make things more cost-effective, we are able to find better ways of staying alive up there, but also being able to go further distances.
Okay, well, we had about, according to what I was just doing, I don't know, 70 people or so watching, and that was kind of cool, and we got a lot of interaction live. I know that the time zone isn't ideal for people in Europe. We'll play with that and try to make some more European-friendly time zone events, as well as ones that are better for the other side of the world as well. So, but right now, since this is an experiment, we're sticking with what we can do. So.
Yeah.
I guess we will.
Do you have anything coming up, Tony?
Do I have anything coming up?
Yeah. Is there any other Hubble Hangouts? Any new posts?
Yeah. So if you're not subscribing to the Hubble Space Telescope G+ page or the Hubble Site channel, YouTube channel, then do that, and you'll get notified of whenever future Hangouts occur, Hangouts on air. I don't have anything specifically planned coming up, but I do have Alberto and Scott and I will be having some in January. I just don't know when.
Right.
The problem is getting people to their schedules. There's a lot of scheduling things. So let me know what you guys think of this. Is it too long? Do you want it shorter? Should we keep it to 10 minutes? Should we keep it to 15 minutes?
Should we go for an 8-hour marathon now that we can?
No. Don't do that one. But yeah, so let us know you'll, as always, you vote with your views and your comments. So thank you all for watching. I really appreciate it. This was fun for me. I had fun, and Scott, thank you, dude, man. You really made it possible, because I can't do everything. I couldn't have done all that without you. So
well,
thank you very much.
I do have 12 arms over here. Just
you do.
10 of them are invisible.
You are a social media ninja, dude. I don't know how you do it. Anyway, okay. Thank you guys. See you next week. Same bat time, same bat channel. And
Keep
I'll
looking
have to watch
up.
BBC Stargazing Live. See what
It's
they
a great. Have you ever seen it? You've seen it.
No, I'm not.
Oh, it's so good. It's really good.
Okay, all right. I will watch.
And it's because of Dara O'Brien. He's my favorite person ever. Thumbs up for Dara O'Brien. Thumbs up for Dara O'Brien. All right.